Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem search in rotated sorted array. So the problem statement says that there is an integer array nums sorted in ascending order with distinct values. All the values are unique and it is sorted in ascending order. Alright, now we can see that with prior to being passed to your function nums is possibly left rotated at an unknown index k where k is lying from 1 to nums of length, alright, such that resulting array is nums of k plus 1 and so on. And for example 0 1 2 4 5 6 7 is given and might be left rotated by three indices which becomes which becomes this if it is left rotated by three indices, it means that the first element will move to the last index if we rotate one time. So the 0 will be moved to the rightmost place, and in the second rotation, 1 will also move. In the third rotation, 2 will also move. So we will get it like 4 5 6 7 0 1 2. So it's basically left rotated. We are rotating left. Okay, and now given the array nums after the possible rotation and an integer target, return the index of target if it is in nums or -1 if it is not in nums. So basically we can see we are given an array and then target, and the array, it is sorted but it is rotated also. So from somewhere we can see that this is sorted. 0 1 2 is sorted, and 4 5 6 7 is sorted. So we can just see that our array will not be fully sorted, but this will be sorted in, if we observe, it will be sorted in two parts. First first we can see that 4 5 6 7 till here, and then 0 1 2. So we can say that our array will be sorted uh, in two parts. We can see that our array is divided in two parts and both parts will be sorted. Just simple, because it is rotated. Alright, and what we have to do, we are given the target, let's say here 0, and if written the index of target if it is in nums. So if this target is inside the nums, we have to return the index. Otherwise, we have to return -1. So is 0 existing here? Yes, it is existing. And what is the index here? If 0 based indexing is there, 4, 0, 1, 2, 3, 4. So output is 4. And similarly here, target 3. 3 is not here. So we have to return -1. So just we have to solve this problem. So I am taking the same example here, 4, 5, 6, 7, 0, 1, 2. So we have this array, nums array. This is our nums array. And now we have to solve for it. Okay. So what we observe first? First of all, the basic brute force approach, that we can check the whole array from the starting to the ending and just check whether this target, let's say what was the target, 0. So let's say our target is what, 0. So first option is that we do manual check uh, from starting from 0th index to the n minus 1th index, but this will take big of n time complexity, which is not acceptable because here it is mentioned that we must write an algorithm with big of log n time complexity. So now what we can do, so log n time complexity is there, so and search is also there, and sorted is also there. So binary search will obviously come in our mind, but binary search applies in a sorted array, but this array is not fully sorted but rotatedly sorted. So if we see here, if we divide this array in two parts, this part is sorted and this part is sorted, but combining whole array is not sorted, because here it was written that this array was rotated uh, from the left. That's why. So now how we can apply binary search in a rotated sorted array? So we will learn now. So first thing, that what do we do in normal binary search? We have a low, we have a high, and we go and find mid. So what is our low? If first of all I will write the indexes. So indexes are 0, 1, 2, 3, 4, 5, 6. Now if we have to search in the whole array, obviously our low will be 0, our low will be 0, and our high will be n minus 1, and that is 6. So our mid is what? 6 plus 0, 6 by 2, that is 3. So mid is 3. And now where we are? We are basically on the third index. We are here. Now what? Now we first of all, obviously, uh, if the value is equal to the target, we will return the index. If it is not equal to the target, either we have to move right, or either we have to move right, or either we have to move left. So how we will decide where to move, right or left? Because if this array was fully sorted, then it was very easy for us to decide that whether to move right side or left side. But this array we can see is not sorted, I mean rotatedly sorted. So it's difficult for us to decide whether to where to move, left or right. So there is a trick. There is an observation, basically what I told earlier in the starting, that we know that this array, if we divide, if we divide, if I divide from here, we can see that from here this portion is sorted and this portion is not sorted. All right. So what we can do is, let's say we are standing here at the mid, it is where the index number is 3. So it is sure, it is guaranteed that one of the either sides from this index, that is either this side or this side, will be sorted. One of them will be fully sorted. So if I'm standing at this uh, uh, index, we can see that from here left portion is sorted, because we get the element as 4, 5, 6 here on the left, and on the right we get 0, 1, 2. Yes, both are sorted, but yes, if both are sorted, we can check in both. What I need to check, that let's say first we have to check which side is sorted. Is if First of all we will check left side. If left side is sorted, then we can, if suppose left side is sorted, uh, then we can easily check that whether this target lies between this or not. Because if any if we have any set of elements, 4, 5, 6, and we have target 0, and we have to check whether this lies in this range or not. We can simply check how, because here will be our low, and this 6 will be our what, mid minus 1, mid minus 1. So we can simply check that whether this target lies between low and mid or not. If it is lying, then we can see, we can just say that we have to move left side. So similarly here, that if I am starting at mid and mid is not my answer, then I have to decide whether either to move left side or right side. But how we will decide? Because how we will decide? So the only way is that we will move to that side where our answer will be. So how we will check that where our answer will be? So the answer will be there only where the target is lying, where this 0 is lying. So we need to just check, is 0 lying on the left side or on the right side. So just we have to determine that. First of all, we will check left, and if it is sorted, if left part is sorted, then we can just easily check, because this will be my low, because this will be my low, all right, and this was already my mid. So I can just simply check that is 0 lying between low and mid. How? Nums of low is 4 and nums of mid is 7. Is 0 lying between 4 and 7? No. It means that definitely my answer is not on the left side. It means that guaranteed I have to move to right. Obviously I have to move to right. So from here we decide that we have to move to right. Here we decide that we have to move to right. So now we will move to right. And now if I have to move to right, what I have to do? I have to increase my low to mid plus 1. So now my low will be what? Mid plus 1, that is 4. That is 4. Now that is 4. And now my new mid is 6 plus 4, 10 by 2, that is 5. So now my, let me write it. Now where are we standing? My mid is 5. So now we are standing at this index element. Now again, from the property here, that it is guaranteed that either of the side, either uh, of the two sides, either left or right, one of them will be definitely sorted. Both can be sorted if we are at the middle of, if we are standing at the division. So both sides can be sorted. But if we are standing at any random index, any one of any side will be sorted. If you do not believe, I am telling you also that, let me take an example. Same similar array, 4, 5, 6, 7, 0, 1, 2. So let's say I'm starting, if I'm standing, if I make, let's say if I'm standing here, all right. So at the left we can say, see that this whole uh, arrays, this whole set of elements are sorted. 4 single elements sorted. If I'm standing here, I can see that this is sorted and this is not sorted. If I'm standing here, I can see that this is sorted. If I'm standing here, this again is sorted. If I'm standing here, I can see that this portion is not sorted, but I can see that the left one is sorted. So it is guaranteed that either one of these two sides will be sorted, because this is an sorted array but rotated. So it is guaranteed that one of either sides will be sorted. Both can be sorted when? Because both can be sorted if we are standing, let's say, at 0. So we can see that 1, 2 is also sorted, and 4, 5, 6, 7 both are sorted. All right. So it's very easy for us to determine where to move. So if I'm standing at this index 5, mid is 5, and now firstly I have to check, is it equal to target? It is not equal to target. So if it is not equal to target, again I have to decide where to move. So either I can move to left side or I have to move to right side to find my target. So how will I decide? First of all, I will determine which side is salted. Then I can decide that whether the target lies in that salted part or not. So if this left is the left part sorted, how we can determine? Our left was 4. This was our left. This is mid and high was 6. So just we can check that is uh, low less than or equal to mid, but not necessary to check equal to, because all the elements are distinct. In the starting we can check see. Now is low less than equal to mid? We can check firstly on the left side, that is low less than mid. Yes, low is less than mid. It means that left part is sorted. Yes, left part is sorted. So now if left part is sorted, now we can check that uh, is 0 lying in this range low to mid. So if we check that is 0 lying between 0 to 1, yes, 0 is lying between 0 to 1. So now we will move left side. All right, and we can also check this from the right side also. All right, but here we can see that, okay, if you want to check, right first. So if you will check right first, you will see that, okay, right part is sorted, and now we will check that target 0 is target 0 lying between 1 and 2. No, it means that we don't have to move right side, it means we have to move left side. Now we will move left side. So now if we have to move left side, what will be my high? High will be my mid minus 1, that is 4. So high will be my 4. High will be 4, and now mid will also be 4 plus 4, 8 by 2, 4. So now you can easily see that where I'm going to land, that I'm going to stand at the mid, that is 4. And now first of all I will check that if this index element is equal to target, is 0 equal to target, is 0 equal to 0? Yes, 0 is equals to 0. It means that we have found our target. And yes, now we can return the index, that is 4, and we can see our answer is also 4. And let's say our target was 3. So if the target was 3, then we have to start from starting, because if we try to find 3, we will not be able to find 3 here anywhere. If we will apply the same algorithm, we will not able to find, and one time will come when our low will be greater than high, and in that case we can just uh, move out of while loop, and then we can return minus 1. So this was the simple logic, that how to apply binary search on rotated sorted array. So if I go and just implement it, so first of all I would like to uh, declare the size of the nums variable, nums dot size. And now what we were first doing, so first of all my low will be what, 0, and high will be what, n minus 1. And now I will apply binary search, so I will move only when my low will be less than equal to high. And now I will find mid will be what, low plus high minus low by 2. And now first of all what I will check, that if my nums of mid is equal to target, then simply we can just return the index without any problem, that is mid. We will return mid because we have to return index here. And now if it's not our target, either we have to move left or right. So first of all I will check, is left sorted, is left sorted. So if left will be sorted, then how I can check? If left part will be sorted, then definitely nums of low will be less than mid, because I'm not writing here equal to, because every elements are distinct. So if nums of low is less than nums of mid, it definitely makes sense that left part is sorted. And now we can just simply check here that whether target lies in between that range or not. So if target is what, greater than equal to nums of low, and if target is lying between these range, so target will be greater than equal to nums of low. Here equal to, because nums of low can be our target, all right, and target is less than equal to nums of high. Now if then what we have to do, it means that we have to move left side, and for moving to left side, what we used to do, we have to if we have to move to left side, we have to reduce high. So high will be what, mid minus 1. And in the else case, if our target is not lying on the left side, we have to move right side. So for moving to right side, my low will be equal to mid plus 1. And similarly, in the else case will be what, uh, right part is sorted, right part is sorted. So if my right part will be sorted, it means I'm copying the same thing here, but just I will make some few changes, because the pattern is same. So now I will check that whether my target is lying between that sorted part or not. So what will be that part? Nums target should be greater than equal to mid, and target should be less than equal to uh, target wait, if when my left part was sorted, then target should lie between low and mid, because I'm checking for the left side. And for the right side, if my target is between mid and high, then it means that I have to move to the what, right side. And for moving to the right side, I have to move to the right side. So low will be my mid plus 1. And if my right uh, if my target does not lies on the right side, then it means that I have to move to the left side. So for moving to the left side, I will write high is equals to mid minus 1. And in the else case, when nothing happens and I'm out of the loop, it means that I have not found my target, and I will return minus 1. And now if I run this and check whether we are able to pass the sample test cases or not. So we are able to pass the sample test cases, and if I submit it and check whether we are able to submit all the test cases or not, so we can see that we are getting some error here, that is 3 and 1. So for 3 and 1, uh, target is 1 and output is minus 1. So if I dry run it and just check that for 3 and 1, this index number is 0 1, low will be equal to 0, high will be equal to 1, and mid will be equal to 0. So I will be here, mid will be here. And now first of all, we will check that this is our target. No, this is not our target. Is left sorted, so nums of low is less than mid, less than mid. If nums of low, that is nums of low is what, 3, and nums of low is 3, and this is 3. So uh, low and mid both are same. So this will be false. In my case, this will be false. Nums of low is less than nums of mid, false. So we will check in the else part that if target is greater than equal to nums of mid, and target is less than equal to nums of high. So when this will check that is target lying between the 3 and 1, is target lying between 3 and 1, at 1 is lying between 3 and 1, this will say false, and it will move high to mid minus 1, that is minus 1, and next time this will go out of loop and return minus 1. But see, we what error we made here, I made here, that I have written here nums of low less than nums of mid. That was my whole blunder during interpreting the problem, because I didn't take thought in my mind that my what if there was only one element left. So that didn't came into my mind. That was the edge case. That if there is only one element, then low, mid, and high both will be same. And if nums of low is less than equal to nums of mid, let's say let's say two elements are also there. Let's say this only 3 and 1 is also there. So this was the low, this was the mid, and this was the high. So if I'm standing here where both low and mid are the same, and if I check that if nums of low is less than nums of mid, this is wrong. I should check here, I should write here that this is nums if nums of low is less than equal to nums of mid, because there can be also only one element on the left side. So that edge case we are missing. So now this will return true, and now we will check that is target lying between, is my target lying between nums of low, that is 3, and nums of mid. So is my target lying between 3 and 3? So no. So now what it will do, that it will move me to right side, that is low is equals to mid plus 1. So low will be now mid plus 1, that is 1, and now my mid will also be 1. And when as I will move to 1, I will see that my nums of mid is equal to target, and I will return 1. So now if I submit this, so I think this should pass all the test cases now. 3 test cases were left at the last, and yes, we have solved this problem. So the only mistake I made was I didn't thought of that one edge case, that on the left side there can only be one element left. So for that, I should say, I should write here nums of low is less than equal to nums of mid. So we solved this problem. And if I talk about the time and space complexity, so we all know in the question it was also written that time complexity complexity they need is big of log n, because this is binary search, and we all know that from where this log n came. All right, and if you want, I can explain that also, from that why big O of log n time complexity is there for binary search. And space complexity, we are not taking any space, so space complexity is big O of 1. So this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.